I think it is visible now.
Yes, sir.
Okay. So I'm again explaining it. So here what happens, that here A is given as x belonging to z, such that x is between 0 to 12. So what does z mean? Z means integers. So what are the integers between 0 to 12? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the integers, including 0 and 12. Now it is saying that S is a relation which is a comma b, such that ab belonging to integer and mod of a minus b is divisible by 4. So here, if you take suppose any element, suppose you are taking 3, for example, you are taking 3. So 3 can be paired with 7, because we know that 3 minus 7 is equal to minus 4, and if you are taking mod, then it will become 4, which is divisible by 4, right? What else you can pair 3 with? 3 can be paired with 11, because if you take 3 minus 11, it will become minus 8, which will become 8, and it is divisible by 4. 8 is also divisible by 4. So mod of a minus b is divisible by 4, and so 3 is paired with 7, 3 is paired with 11. Similarly, you can pair 6 with 10, 6 with 2, so that the difference should be the multiple of 4. Now what it is saying, that show that the relation S given by this is an equivalence relation, and find the set of all elements related to 1. So equivalence relation, if you want to show, then mod of a minus a is 0, which is divisible by 4. So you will say that it is reflexive because a is related to a. Okay. Now for symmetric, if a minus b mod is divisible by 4, this simply means that mod of b minus a is also divisible by 4. Okay, if you take opposite also, like 3 minus 7 is minus 4, and mod of minus 4 is 4. And if you take 7 minus 3 mod, then also it will be 4. So it is symmetric also, right? For reflect transitive, you will say that if mod of a minus b is divisible by 4 and mod of b minus c is divisible by 4, so what it means? It means a minus b is a multiple of 4, 4k1. B minus C is a multiple of 4, 4k2 suppose. And if you will add them, if you add this equation with this equation, so on adding, what will happen? Minus B and plus B will cancel. A minus C will become 4 k1 plus k2. So k1 plus k2 is also an integer, so it will be 4k. So a minus C is 4k, which means mod of a minus C is divisible by 4. So we say that it is transitive also. So if it is reflexive, symmetric, and transitive, therefore it is an equivalence relation. This is an equivalence relation, right? So first we have checked for reflexive, then we have checked for symmetric, then we have checked for transitive. Further, it was saying that find the set of all elements related to 1. So related to 1, if you want to find the elements there, so 1 is related to 5 because 1 minus 5 is minus 4, which is divisible by 4. 1 is related to 9 because 1 minus 9 is minus 8, and minus 8 mod is 8, which is divisible by 4. Then it should be 1 comma 13, but 13 is not present here. So we will say that 1 is related to 5 and 1 is related to 9. So this will be the answer of the second part. So I hope you are getting it. Is it okay, Ali? If you have not understood any step, you can ask. Okay, you can write it down. And I think you want to start determinants today, right? First write this down, then we will start. Okay, matrices you want to start. Okay, fine, we will start matrices. So let me change the name here. You can write it down. Okay, done till here. I'm scrolling it now. Yes, Sadia, I'm scrolling it down. Okay, done. Fine. So let us start matrices now. So in matrices, first of all, it is arrangement of numbers, or we can also say functions. Okay, sometimes there are functions also. For example, in numbers, suppose there are two persons, Suhail and um, Ronit. Now suppose Suhail is having pen, pencil and a scale. So Suhail is having 3 pen, Suhail is having 7 pencils and 0 scale. Ronit is having 1 pen, 2 pencil and 3 scales. So this is an array, this is a information. So if we want to write this information in a particular format, we use matrices. So we arrange this number of functions. So we write it like this, that we have 3, 7, 0, 1, 2, 3. So this is arrangement of numbers. The row means that it is Suhal, and the second row means it is Ronit. Column means that it is pen, first column, second column means pencil, third column means a scale. So everywhere in the question it is not given that what it means, but in the background there is some meaning to every row and every column. But when we are talking about the operations on matrices and the numericals on matrices, we are not going into the detail that what they represent actually. That is another thing. So basically this is a way. Now here there is something called order of a matrix. So if you see this matrix, this is having number of rows, which is, we take m, here number of rows is 2, and number of columns. So number of columns we generally call n, here it is 3. So order of matrix is 2 cross 3, which we call m cross n, number of rows into number of columns. So we write it like this. Now there are various type of matrices. So let us see few type of matrices which we have to study. First write till here, starting from here. I'm scrolling it down. We generally denote a matrix by a capital letter, suppose A. So A matrix is 3, 7, 0, 1, 2, 3. And we can write here it is having 2 rows into 3 columns. Or we can also represent a matrix with its order like this. Now, one more thing which we should know about matrices is that matrix elements are sometimes written like this: A11, A12, A13, A1n, then A21, A22, A23, A2n. And like this, we come to the mth row, AM1 and AM2 and AM3, AM3, AMN. So these are the elements. So what we call them, suppose if we are talking about A32, okay, A32 will be an element here. This is A32. So A32 means third row, second column element. So in general, if it is Aij, I means ith row element and J means jth column element. And we can also write a matrix like this, that this is a matrix whose elements are Aij. And we can write here m cross n. That means m rows are there and n columns are there. So for example, in the above case, we had how many elements? We had A11, A12, A13, A21, A22, A23. So in that example, we took 370123. So 370123. So these were the elements, and this matrix was 2 cross 3 matrix. So you can write this also here. So I hope you have written this. Okay. If you have not written, you can tell. Otherwise, we are proceeding further, right? So types of matrices we are talking about right now. So type of matrices, first of all, we call a row matrix. So as the name suggests, that row matrix is a matrix which is having only one row. Number of columns can be as many as possible, but row is one. So A is a matrix with element 2, -3, 0.5, and root 2. So this is a matrix. It is having real numbers. Real numbers could be negative also, could be in fraction, decimal also, could be in irrational also, root 2 also. So this is a matrix. Its order is 1 cross 4. So number of rows here is equal to 1 and number of columns are here equal to 4. So it is 1 cross 4 matrix. This is a row matrix. Then we have something called column matrix. Column matrix, we have number of column is equal to 1. So number of column is equal to 1 means suppose B is a matrix and it is having element minus 1, 2, 3 by 7. Let us take like this. So this is 3 cross 1. So number of rows, if you will see here, there are 3, and number of column, if you see here, there are 1. So column matrix basically is this, and this is the row matrix. Then we have something called a square matrix. So in this number is 3 by 7, right? This number I have shown here is only one number. It is in fraction 3 by 7. Then we have something called a square matrix. If we say a square matrix, then it means that number of rows is equal to number of columns. So number of rows and number of columns are same. For example, the most common matrix which we will come across is 3 cross 3 matrix. So I'm giving an example of 3 cross 3 matrix. Suppose C matrix is there. 1, 0, minus 2, 3, 4, 13, minus 5, root 2, 0. So this is a 3 cross 3 matrix. Number of rows which is equal to m and number of columns which is equal to n, both are equal to 3. So therefore m is equal to n. So this is called a square matrix. And in a square matrix, there is something called principal diagonal, or we can simply call it diagonal also. Principal diagonal, or we can just call it diagonal. So diagonal is basically the elements, these elements are the elements of the diagonal. So these elements are A11, A22, A33. That means first row, first column element, second row, second column element, third row, third column element. If it is a larger matrix, then fourth row, fourth column element, like this. So these are the elements of the diagonal. These are the elements of the diagonal of a square matrix. So you don't have to worry that this is also a diagonal. Some may think that suppose we have this here, this one, this should also be called a diagonal, but this is not called a diagonal of the matrix. Diagonal is this one, which is also the principal diagonal. This is not called the diagonal. So you can write till here, starting from here. We have more types of matrices, but first write till here. Yes, Ali, this is 1 hour class. Okay, done. Okay, done. Okay, done. Fine. Now these three type of matrices we have studied. Then we have fourth type of matrix, which is called diagonal matrix. So what is a diagonal matrix? Its non-diagonal elements are zero, and it is also a square type of square matrix. It is a square matrix. It is a square matrix, and in this square matrix, non-diagonal elements are zero. So, for example, we can have a matrix A, which is 3 0 0 0 minus 1 0 0 0 root 2. So this is a diagonal matrix. This is example of a diagonal matrix because it's non-diagonal elements that you know what are diagonal elements? These elements are the diagonal elements. So if you talk about non-diagonal elements, rest of the elements, they are actually equal to zero. In other words, you can say that Aij is equal to zero if I is not equal to j. Like here A12, A13, A21, A23, A31, A32, these are all 0. So A11 is not 0, A22 is not 0, A33 is not 0, rest are 0. One more thing you have to keep in mind here, that there is no condition on diagonal elements. We are not saying that diagonal elements are non-zero. Diagonal elements can also be 0. For example, we can take a matrix B like this: 2 0 0 0 0 3 0 0 and then 0 and 0 0 minus 1. So this is also a diagonal matrix because its non-diagonal elements, these are non-diagonal elements. The non-diagonal elements are all 0. Though there is a diagonal element also which is 0, but that is not a problem. The condition is no condition on diagonal elements, that a diagonal element should be 0 or should be non-zero. There is no condition like that. The condition is on non-diagonal elements. So non-diagonal elements must be 0. So write this. Okay, done till here. Okay, done. Fine. Now this is the fourth type of matrix, diagonal matrix. Then we have fifth type of matrix, which is called a scalar matrix. So a scalar matrix is further a special case of this diagonal matrix. So it is a diagonal matrix. So what is a diagonal matrix? We know that whose non-diagonal elements are 0, but there is no condition on diagonal elements. But here it is a diagonal matrix whose diagonal elements are equal. Okay. So of course non-diagonal elements are 0, as it is a diagonal matrix only. So its non-diagonal elements are 0, whereas diagonal elements are equal. So if it is 7, this is also 7, this is also 7. They are all equal. So this is a scalar matrix. So you can say that A I is same for I equal to 1, 2, 3. If it is a bigger matrix, then so on. So I is same. So this is scalar matrix. Another type of matrix is called identity matrix. It is a very important matrix. You will come across identity matrix a lot. Identity matrix is a further a special case of a scalar matrix. So it is a scalar matrix. In a scalar matrix, the condition was that the diagonal elements are same. Here, diagonal elements are of course same and are equal to 1. So this is a specific matrix. You should not give any example. There is only one possibility: 1, 1, 1, 0, 0, 0, 0, 0, 0, and we denote it by capital I. So this is an identity matrix. This is an identity matrix 3 cross 3. The identity matrix could be 2 cross 2 also, like we can have 1, 1, 0, 0. So 2 row, 2 column. Diagonal elements are 1, non-diagonal elements are 0. So you can write them. Have you written, Ali? Okay. So what we have to remember is that these type of matrices which we have started studying from here, like diagonal matrix is only possible for a square matrix. That is, number of rows and number of columns should be same. A scalar matrix is of course a diagonal matrix, so this is also a square matrix. And identity matrix जो है, that is also a square matrix. Now we have zero matrix. So this is seventh type. Zero matrix is also an important matrix. It is not necessarily a square. It is a rectangular matrix. Rectangular means a square is also included there. So rectangular matrix, suppose A is equal to 0, 0, 0, 0, 0, 0. All the elements are 0. So this is a matrix A having element 0, and this is a 2 row 3 column matrix. We can have a matrix, a square matrix also, 0, 0. So B is equal to having element 0, 2 cross 2 matrix. So zero matrix means all the elements are 0, simply like that. Okay, write this one. Okay. So we have next is equality of matrices. So next topic we have is equality of matrices. Two matrices are called compatible for checking equality if they are of the same order. So first condition is that the matrix should have the same order. Then only you can compare for equality of matrices. Another condition is that corresponding elements, after that we will check corresponding elements are equal. Corresponding elements are equal. So for example, if we have a matrix x 0 minus 2 y x plus z 3, and this matrix we are saying is equal to 1 0, and let us take x minus 3. Okay, and then okay, so I'm taking these two equal matrices. Okay, if we are talking that these two are matrices which are equal matrices, then their order should be same. So this is having order 2 cross 3, this is having order 2 cross 3, so they can be checked for equality. Now corresponding elements, x should be equal to 1, fine, and then this 0 should be equal to 0, that is also fine. Okay, first row second column element, then minus 2 should be equal to x minus 3. So x minus 3 is equal to minus 2. So x is equal to 3 minus 2, which is equal to 1. So you have to check whether we have got the correct answer or not. So in this case, we got x is equal to 1 when we compared this first row, first column element. And after comparing first row, third column element, x minus 3 is equal to minus 2, we are again getting x is equal to 1. That is, we are fine till now. Then we come here, y, and it is minus 2. Y is equal to minus 2. Okay. Then we have x plus z is equal to 5. So x plus z is equal to 5. X we already know. X is 1. We have got here also. We have got here also. So 1 plus z is equal to 5, which means z is equal to 5 minus 1, 4. So z should be 4 if we want these two matrices to be equal matrix. Then we have 3, and this should be equal to z minus 1. So 3 is equal to z minus 1, which means z is equal to 3 plus 1, 4. So this z is equal to 4 and this z is equal to 4 is same. So that means for the value x is equal to 1, y is equal to minus 2, and z is equal to 4. These three values, if we take of x, y, z, we can say that then the given matrices are equal. But we can say that the given matrices are equal. Sometimes it may not be possible. Like if you given here z plus 1, if we take z plus 1, what will happen? Z plus 1 is equal to 3 we will do. So z is equal to 2. But here z is coming out to be 4 by another condition. So both cannot be possible simultaneously. So these two matrices can never be equal. So we have to check that all the conditions must be satisfied. All the corresponding elements must be equal. Now you can write this equality of matrices. When you have completed writing, Ali, you can tell. I will scroll it down. Okay, done. So for these values of x, y, and z, these matrices are equal. If you take any other value of x or y or z other than these values, for any one of them, if you take, or for more than one of them, then the matrices will not be equal.